we're going to talk a little bit about standard form. This is another form that you'll find equations in for linear equations that make lines. This form is used for quickness and to find x and y intercepts as well as slope. The form is ax plus by is equal to c. C is our constant, so it's equal to c. So when we look here at ax plus by equals c, we see that a, b, and c have to all be real numbers, and a and b cannot both be 0 at the same time. So for example, if I put in a 0 for a, and it was times whatever number for my coordinate, then I know it would equal 0. If I have b also 0, then it's going to equal 0, and a 0 plus a 0 can never equal another number, and if it equals 0, then there's really not a line. So think about what this means. All right, so our first example, we're going to take slope-intercept form 3x plus 4y equals 12, and we're going to find the x-intercept and the y-intercept, and then be able to graph it on a graph. So if you think about when you're looking for a y-intercept and an x-intercept, you know its opposing point is going to be 0. So let's look at our x-intercept first. When we're looking for what is x, we're looking for something, a number that's going to hit on the x-axis, and that means y is going to be 0. So if we take our equation, 3x, and we're looking for the x, so we've got to solve for it, plus 4, and we know the y is going to be 0, we're going to solve now for the x. Well, 4 times 0 is nothing, so we're left with 3x is equal to 12, and we're going to solve for the x. So we know that the x is 4. So now we have that the x is 4, we can then plot that on our graph. 0, 4, or 4, 0, excuse me. 4 over, and we don't move up at all on the y-intercept. So we have an x-intercept of 4, 0, and I've plotted it on the x-axis. So we're going to do the same thing now for the y-intercept. So when the y-intercept, we're looking for when x is 0. So we're going to plug in 3 times 0 plus 4y equals 12. So now 3 times 0 is nothing. Then we have 4y is equal to 12. Divide by 4, y equals 3. So we know that the y-intercept is 0, 3. And we can now plot that on our graph. And you can take then a line and connect those, and you have your graph done. All right, second one, we're going to do the same thing. What I like to do is use a finger method. So if I'm looking for the x-intercept, I'm looking for x when the y is going to be 0. So I'm going to kind of highlight and mark that out. So we know that's 0. So 2 times 0 is going to be 0. So we're left, oh, I made a mistake here. This should be a, we're at the wrong number here. This here, it's not a 0. This is a negative 10. There we go. All right, so when this is 0, then I have 5x is equal to negative 10. Well, if I divide by 5 and divide by 5, I end up with x equals negative 2. So now I can graph my negative 2, 0, and I have my x-intercept. I'm going to do the same thing for my y. So let's clear what I've done here. Let's put it back. I still need to fix that little thing there. Let's now solve for the other. All right, so we had a negative 2 here and 0. So now we're going to solve for the other. So we're going to put in 0 for our x here. So that means this is gone. And I have 2y, and then keep erasing that there. That's a negative 10. And divide by 2. Divide by 2. Then I have a negative 5. So when x is 0, my y-intercept is a negative 5. So let's put our graph back here. And we will plot our points. So we had a negative 2, 0 for our x-intercept, and for our y-intercept, it's a 0, negative 5 here, and then we could take our lines and connect them. Got off a little bit there, and we would have a graph for us. All right, so the same way here. So pause the video and see if you can now find out what the x and y-intercepts are and how to put it on the graph. All right, so you should have for your x-intercept 6, 0, and your y-intercept 0, negative 2. and we've graphed it here, and we have it on the graph. All right, remember we talked a little bit about two special types of lines. X is a -3, y is -3, and x is 2. How will we graph those? So when we look at y equals -3, we do not see an x value in there at all. So this tells us there's a 0 slope. So remember, y equals -3s. Those are going to go across our graph where it intersects the y-axis. So if it intersects at the -3 here, we're going to have to graph it at the -3. So 1, 2, 3, and then our line goes out from here. That is a line of a special line. That's a horizontal line that has a 0 slope. And then the x equals 2, those are always going to be vertical lines. And it's going to intersect where it hits the x-axis. X is 2, so that's hitting there. So here's our x is 2, and it's going to be a vertical line, so forth as you see graphed there. So remember about these two special types of lines. All right, we're going to use a new formula today, finding slope using the standard form. The formula is m equals -a over b. So we're going to look at our equation that we're given in standard form, and we're going to look at the a value. Remember, it's right here beside the x. Sometimes they'll try to switch them up on you and confuse you, but you need to have it in this form to be able to get it accurate. So we're going to look at what a is now. Well, a right now is a 3. So we're going to do the opposite of 3. So we're going to do a -3. And then we're going to put it over, so divided by whatever b is. Well, b is 4. So our slope is a -3/4. That's simple. So always a -a over b. Let's try another one. So here's a couple more for you to try. See if you can find the slopes of these two in standard form using the simple formula m equals -a over b. So for b, we have -5 over 2. It was a +5, so we get putting negative the opposite, -5 over our +2 in our b spot. And then the bottom one, it had a +2, so we put it in as a -2 over our b. That negative goes with it, -6. So -2 divided by -6 gives us 1/3. All right, so our last little section here is we've got to be able to change equations to standard form from slope-intercept form. So we've talked a little bit about y equals and solving for y equals. And so you're going to then now take and move these to standard form. So we want to know that we always want to have the a being positive, and the a is always the number beside the x, and we do not want to have fractions in our standard form equation. So those are our two kind of unwritten rules that we have to remember. They're not going to really remind you about. You have to be very careful with those. So we're going to get x and y's on the same side first. So we're going to do plus 4x plus 4x. So we end up with 4x plus y is equal to -3. Now you have it in standard form. You easily can then double check. We know that our slope to begin with was a -4 and our y-intercept was -3. You can use your different formulas and how to find your x and y-intercepts, and you can double check yourself to make sure you're right. Very simple. All right, let's try one more. So we do -2x, -2x. So when we move this one over, these are gone. We have -2x plus y is equal to 5. But we have a negative here in front of our a spot. We do not want that. So to get rid of it, we can multiply the whole thing times -1. A negative times a negative is positive. Basically, it changes every sign. So this becomes a -y, and then this also becomes a -5. So this is in standard form now with our a being positive, and there's no fractions. All right, try this one and see if you can get this one to change. Remember, no fractions, and you want a to be positive. All right, how did you do? All right, let's try one with a fraction in it. So the first thing we want to do is we want to clear the fraction. Remember, we do not want to have fractions inside of a standard form. So we're going to go ahead and clear fractions like we've learned previously this year. Our denominator is 2, so we're going to multiply all by 2. 2 times y is 2y is equal to 2 goes into 2 one time. 1 times 3 is 3x. And then 2 times 2 is 4. Now we're going to move things over. Minus 3x, we end up with negative 3x plus 2y is equal to 4. We do not want a negative, so we're going to multiply the whole equation by a negative to get rid of that negative a value. So we have 3x minus 2y is equal to negative 4.